Hello everyone, welcome to the lecture series on database systems. In this video, we will be discussing on database definition languages and see how it can be used. So actually before we can create any structure or database tables, we need to understand the concept of SQL identifiers. So what is identifier? Actually identifier is you can say is set of words or user-defined words that are used to identify or name the objects in the database. So database objects are named and they are identified by these words. So tables, columns each have the name. And this database identifier or say just identifier can be named from the set of characters that are actually in the character set. And so what we can say is that these characters in the identifier must come from the defined character set. ISO provides a standard set of characters that can be used for the identifiers, and these characters include uppercase letters from A to Z. Similarly, the lowercase letters from A to Z, also the digits from 0 to 9, and the underscore character. Also note that you can also possibly specify an alternate character set in the database besides the ISO standard. And finally, there are some restrictions that are imposed on identifier names, like what can be the identifier name. First of all, it is the length of the characters that can be used in the identifier, and ISO defines it as 128 characters. But note that most of the dialects, and by dialect we mean the implementation of SQL, they have actually lower limit than this. So say for example Oracle I think provides 30 characters for the identifier. So there is upper limit on how many number of characters that can be used on the identifier, and also the identifier must start with a letter. By letter it means the character. So the identifier cannot start with digit, and also the identifier cannot contain spaces. So for example there are two letters which are separated with space, so this is not a valid identifier name. If space is required, then underscore is your best bet to separate the words or say a set of words in the identifier. So there are also some other implementation dependent rules and guidelines to name the database objects or say identifiers. So you may want to see the rules for Oracle database or the also MySQL database. So each may have their own set of rules and guidelines on how to name the identifiers. Apart from identifiers, there's also some concept of data types, SQL data types, and these data types are the type of the data that a column can hold. So we know that a table contains columns, and each column may have a certain data type or the type of the data that can be stored in the column. So SQL defines some basic data types that can be used, and the simplest one is the Boolean data type, and it can hold only two values, true and false. The other data type is the character data type, and this character is actually the sequence of characters. Most programming languages call the sequence of characters as a string data type. So it can be related to the string data type. So character is actually the sequence of characters. And then implementation defined character set must be used. So there are two types that can be defined with the character data type. One is character, and simply said as char, and there also a character varying or referred to as varchar. So there are two types that can be used for the character data type. Also note that there is optional length, say the number of characters that a column can hold. So if a column is defined with character data type, optionally a length of number of the characters can be provided for the column length. And also this length by default is 1. It means the column will only be able to hold one character if no length is provided. So what is the difference between the char and varchar? So the difference is simple. So if the string is defined with a fixed length, then if we do not provide all the required characters, then the extra characters that are not provided, so the remaining space is filled with blanks, and the whole thing is then stored on the disk. So say for example, if we define a fixed character length of say 10 characters, and then we only provide the data for the 3 characters, then the remaining 7 characters are filled with blanks, and then these 10 characters are stored on the disk. So 3 actually characters relate to the data, and the 7 characters relate to the blank, and these are not useful. So actually the 10 characters length is actually wasted, our memory is wasted. However, if we use the varchar or character varying data type, then what happens, like if we define a certain length of the column, and then we do not provide all the characters, say for example we only provide 3 characters out of 10 characters, then only those characters which are provided, those are stored on the space. So thereby it actually reduces the memory, or it does not waste the space on the storage space. So 7 characters are actually you can say is saved. The space for the 7 characters is saved if we define the data type of the column as varchar. So it is best that you do not know like how many characters the column will hold. So it is best that to define the character as varchar. But if we know that the column will ultimately hold all the characters, then it is best to define the fixed data type. Then there is exact numeric. So what it means by exact numeric, it means that exact representation of the number is possible. So numeric data type is actually the number, or the say numeric data, and exact numeric data type is stored. So there are 3 parts to the number, and 1 is mandatory and the 2 are optional. So of course a number cannot be represented without any digits. So if there is no digit, then it is not actually the number. So number, so you can say the digits part is necessary. So the number consists of digits, and there are 2 optional things, that is optional decimal point and then optional sign. And sign actually is used to denote the sign of the number, like is it a positive number or is it a negative number. So exact numeric data type also has 2 considerations. One is the precision and the other is scale. So what the precision means is the total number of significant decimal digits. So like how many significant decimal digits are there. So it is actually the precision of the number. And then the scale is the total number of digits after the decimal point. So for example, if we have a number minus 1, 2 or minus 12.345, so the precision of this number is 5 because there are 5 digits, 1, 2, 3 and 4, excluding the decimal point and the sign point. And then this number has a scale of 3. So there are 3 actually digits after the decimal point. So there are several ways of specifying exact numeric data type. Actually there are four in ISO standard: numeric, decimal, integer, small int, and big int. So integer also represented as int, and the decimal as dec. So integer, small int, and big int, these are the whole numbers, you can say. And then numeric or decimal, they can also include the optional decimal point digits. So for example, if we define a numeric data type like numeric 3 comma 1, so it can store maximum 9.99 value. Similarly, if we specify the data type as decimal, it can store five nines before the decimal points and 2 9 after the decimal point. So maximum value that can we store with the number defined as decimal 7 comma 2 is 9999.99. So 99,999.99. So note that numeric and decimal data types store numbers in the decimal notation. Integer is used for the large positive and negative whole numbers, that is without a decimal point notation. And similarly, small int is used for the small positive and negative whole numbers, and big int is used to hold very large numbers. After exact numeric, we have approximate numeric data type. So this approximate numeric data type is used to hold the numbers that do not have exact representation, such as real numbers. So for example, we can say that how many numbers are there between 0 and 1, and they are actually infinite numbers between 0 and 1. So these are represented with approximate numeric data type. So this is similar to scientific notation. For example, we have the mantissa and the power of 10, or say the exponent. So we have 10 to the power of 3. So exponent part is 3. And also we have 5.2 to the exponent 6, and this is positive number, and this is a negative number 0.2 to the exponent of -4. So these types of numbers are actually stored in approximate numeric data type. So there we have 3 of them: float with the precision, real data type, and then double precision. So double precision is actually greater than the float representation. So we will continue these data types into the next video. Thank you for watching. Please keep watching.